We'll proceed in Jacobian in calculus, and we are in phase of cross Jacobian. Cross Jacobian means if I have xy plane, if I have xy plane and there is z, so xy plane and z. What is z? Z is dependent upon xy plane. If I have x-axis, y-axis, z-axis, all three are not independent to each other. X is independent to y and y is independent to x. Z is dependent upon xy plane, not on x and y, xy plane. So indirectly, z is dependent upon x, z is dependent upon y. So if I have xy plane and there is a z value, it constitutes a surface. So cross Jacobian is d surface area in xy plane. In xy plane, if I draw a area, consider I am drawing a rectangle here. In xy plane, I am drawing a rectangle here. This rectangle would map into some region area in the surface z. Now, in this surface, d surface by dxy plane, d surface d surface by dxy plane, that is nothing but if I take any point on the surface, I'm not talking about full surface, I'm talking about the mapped region. That region is mapped from the xy plane in from a rectangular region. From a rectangular region, then there is a mapped region on the surface. In that region, if I take any point P, then position vector of P is xi plus yj plus zk, where the point P is x comma y comma z, x minus 0 origin I plus y minus 0 j plus z minus 0 k. If that is the case, then dp by dx cross dp by dy. dp by dx is I xi plus yj plus zk I plus dz by dxk. dp by dy is j plus dz by dyk. If this is x-axis and this is z-axis, then dp by dx, it kind of hangs in xz plane. dz by dy hangs, sorry, dp by dy, dp by dy and dz by dy are different. dz by dx and dp by dx is different. If this is position vector and this is x-axis, if I make little bit change in x-axis, then position vector shifts like this. How much this position vector changes per unit change in x-axis, that is dp by dx. If for this position vector, if this is z, and with new x, this is the position vector and this is the z, then there is this much difference came in z because movement, little bit movement in x. dz by dx, if I make one unit change, how much height changes? dz by dx, dp by dx, dp by dx, position vector, how much it is changing. How to know position vector, how much it is changing? Magnitude of the position vector. That is one factor that it is changing, and direction of the position vector. That is another factor, it is changing depending upon the movement of x. So if I see dp by dx, it is I plus dz by dxk. dz by dx is a subset of dp by dx. So dp by dx constitute dz by dx. So dp by dx, it talks about the change in position vector p in xz plane. I plus dz by dx k and I means in xz plane, dp by dy in yz plane. If I do cross product of these two, and if this were xy plane and this is the surface and this is the mapped region on the surface for the rectangle on xy plane, then here the dp by dx cross dp by dy, at this point this is change in the surface area by dxy, the surface area by dxy plane. If there is one unit of change in the rectangle I have drawn on the xy plane, how many unit of area that would change on the mapped surface region. Okay, d surface dp by dx cross product of this vector means I plus dz by dx k cross j plus dz by dy k dp by dx cross dp by dy. If that is the case, then this is nothing but d surface area, change in surface mapped surface area with one unit change in xy plane. So in xy plane, one unit change means one unit change in the area. So if this is xy plane and I have drawn a rectangle here, rectangle can grow one unit, it can shrink one unit change. I'm talking about one unit change, not growth of one unit and shrinkage of one unit, anything. Then how much, if this is xy plane and there is a map for this rectangle region, if there is a map, this region, how much unit of change in area that comes there, dp by dx cross dp by dy. In that dz by dx comes into the picture. So it is d surface area on the mapped surface by dxy plane. If I take magnitude, if you mind it, if someone is in phase to calculate the surface area, okay, if someone is in phase, if someone is in pace, if someone is in run, if someone has a target to calculate the surface area, then d surface area by dxy plane, this is called d surface area, net is called velocity surface area because it is dxy plane. Net surface area would be multiplied by dxy plane in very coarse term. So that is nothing but d surface area by dxy plane, integration with dxy would give the net surface area. So dp by dx cross dp by dy and then integration with dxy, d small d braces x comma y braces closed, dx comma y or dx dy would give the net surface area. We are in phase of calculating the surface area. If I have a cone, so this is what we are discussing, surface area of a cone. Okay, in the name of cone today I have like this. So this is a cone, surface area, surface area of a cone. Cone is kept on xy plane and the reason cone, this cone, I could not find anything better than this. Okay, this cone, this this cone is kept on xy plane and the mapped region on xy plane is a circle. So region on xy plane is a circle because this cone is a circle at the base and top it grows and it comes to a point. This follows cylindrical coordinate system. So this cone maps to a circle on xy plane. So I have to consider the xy plane as a circle. So the region on xy plane is a circle. Now I have to calculate the surface area, this curved surface area of a cone. So if I am calculating this, then it is dp by dx cross dp by dy. If someone calculates this cross product, it comes as and magnitude of it dx dy. So if someone calculates this vector, it comes as minus dz by dxi minus dz by dyj plus k. If magnitude comes the dz by dx whole square plus dz by dy whole square plus 1. Now square root. What is the relationship between z, that is the height, and x and y? We have talked about it. So if this is the base, if this is the base, then this base is a circle. For this circle, there is a radius called small a. At any height z, if I cut it, then it will again be a circle of radius r. Okay, this radius r would rotate full 2 pi 360 degree. At any moment, it is at theta degree angle. At this cross section, if there is a radius r is rotating full 360 degree. At any moment, it will be theta degree from the x-axis. Now x equal to r cos theta, y equal to r sin theta, and this is the height z. Full height is h. The relationship is now this a, that is the base radius a by h. A by a, this if you make a, this full is 2a diameter. A, then there is a triangle. This is height and this is a, radius a and height. At the somewhere there is r and height is z, and this is h minus z. This is r, this is a. A by h is r by h minus z. That is the relationship. So r by h minus z equal to a by h. R by h minus z equal to a by h. If that is the case, then h minus z equal to r into h by a. R into h by a equal to h minus z. Z equal to h minus r into h by a. So z equal to h minus r into a by r into h by a. Whatever. We have z equation. Someone can try dz by dx. Now z equal to h minus r into h by a. So r is the square root of x square plus y square. So z equal to h minus h by a into square root of x square plus y square root. And now dz by dx whole square plus dz by dy whole square plus 1 square root, and then dx dy, where x is minus a to a, y is minus a to a, because it maps a circular region. Minus a to a, y. This is difficult conversion. That's why we go with another coordinate system called cylindrical coordinate system. So now why we are talking about cross Jacobian again and again? Because this is the pioneer. If someone understands cross Jacobian, then he cracks anything in machine learning, artificial intelligence, deep learning, everything. Cross Jacobian. So cross Jacobian, if I have xy plane and if I have a surface over it, then the surface equation, calculation of surface is nothing but dp by dx cross dp by dy magnitude dx dy, and that became as dz by dx whole square plus dz by dy whole square plus 1 square root dx dy. This z in a sphere, it would be a square root of a square minus x square minus y square. Z in cone it is h minus h by h by a into r. That is r is the square root of x square plus y square. So whatever is z, dz by dx whole square plus dz by dy whole square plus 1 square root. If that is the scenario, then someone can proceed in calculating the surface area. But it's not possible. It is very difficult. It is coming as very complex. If that is the case, then we have xy plane. On top of it, we have surface. Now, we will take help of another plane called UVW plane. Here in cylindrical coordinate system, it is theta r z plane or coordinate system. So xy plane is transformed into theta or z coordinate system. But what is equivalent of x and y here? It depends. In theta or z, one I have to discard and two I have to take, whatever it is. But see carefully. This is theta or z. This is theta or z. Or if I go ahead and if I say this is my cone, if this is my cone, this is the cone. If this is the cone, I am trying to calculate the surface area. This surface area, if it is the area, it has two sides. One is vertical side, that is the z component, and one is the arc side, that is the theta component. So theta and z would come into the picture. So the xy plane we have now xy plane and we have now theta z plane, and on xy plane we have a surface. Okay, we are trying to calculate the surface area. The surface is dependent upon xy plane. Xy plane, I want to take it out. Now this surface should directly depend upon the theta z plane. This is called cross Jacobian. So this this surface area was dependent upon xy plane. I'm taking out xy plane. I'm making direct contact of the surface area with the theta z plane. Surface area not directly depending upon theta z plane. This is the pioneer in calculus. So earlier we had d surface area by dxy into dxy to get the full surface area, because xy would cut out and we get the surface area. Now d surface area by dxy into dxy, this dxy can be rewritten as dxy by d theta z into d theta z. Again, see the chain now. Marvelous, right? D surface area by dxy into dxy by d theta z into d theta z. Last d theta z numerator would become d theta dz. Xy gone. Now it is d surface area in xyz. That is the biggest thing. D surface area by d theta z. That is nothing but, if I take any point on the surface area P, that is xi plus yj plus zk, then dp by d theta, because d surface area by d theta z, dp by d theta, cross product dp by dz, magnitude, and d theta dz. Now, if I am talking about dp by d theta cross dp by dz, what is p? P here is xi plus yj plus zk. Now, this is also called parametric vector because we will parameterize it. Now, x equal to r cos theta, y equal to r sin theta. So, if I had taken the cone, the base of the cone is falling on xy plane and it forms a circle over there. The base of this cone is falling on xy plane, and on xy plane it is making a circle over there. This circle has radius small a, but at height z, if I cut it, then it makes another circle with radius r. The full height is h. This height is z. At r, at r, at z height, if there is circle r, the radius r would rotate 360 degree. At any moment, it makes theta angle with x-axis. X equal to r cos theta, y equal to r sin theta. So now we have d surface area by d theta z, that is dp by d theta cross dp by dz, magnitude d theta dz, and then the limit I have to modify. The limit, as we are calculating it, we have modified xy to theta z. Now limit will be in theta z, where z is from 0 to h, and theta is 2 pi. So 2 pi to 0 to h, that is the new limit as per the new coordinate system. Okay, someone can try. If he is not satisfied, then someone can try. Now we have x equal to minus a to a and y equal to minus a to a. We have relationship. Okay, z equal to h minus h by a. Z equal to h minus h by a. H minus z, r by h minus z equal to a by h. H minus z equal to r into h by a. Z equal to h minus r into h by a. R equal to square root of x square plus y square. Now y is minus a to a, x is minus a to a. Someone can try here, and then x equal to r cos theta, y equal to r sin theta. Okay, then if that is the case, then tan theta equal to y by x, theta equal to tan inverse y by x. Now if I see, if intersection, if this is the x-axis xy plane, and this was the cone. The cone intersection on xy plane is a circle. Then x is minus a to a, y is minus a to a. Now x, if I take minus a, then at that point y is 0 on x-axis. Now theta is tan inverse y by x. Y is 0, x is minus a, minus 0. So tan inverse minus 0 is pi, and tan inverse of plus 0 is 0. So the theta would go 0 to pi. Since we had taken Cartesian coordinate system, we are talking about, so theta would, theta, theta would go 0 to pi. So probably it will calculate the, since we had taken Cartesian coordinate system, so we had taken x and y. We will see it, but this is how it is right now. And what about z? Z, we had x is minus a to a, y is minus a to a, x is minus a to a, and y is minus a to a. If that is the scenario, then x is transformed to 0 to pi. This is what we have seen. And then what about y? That is again minus a to a. Okay, that I have transformed into z. We are saying 0 to h. Z equal to h minus h by a into r, square root of x square plus y square. Now when y is minus a to a, then x is 0. So it will come as a. Okay, so a cut down, it will come as a cut down h minus h, 0. So it starts from 0. Similarly, someone has to try it. So it will come as 0 to h, whatever. So someone can give the philosophy that we are following the cylindrical coordinate system. So theta is 0 to pi, okay, and h is 0 to h. But someone can transform also. So it will come as 0 to pi and 0 to h for the full surface area of a cone. And in that case, now integrand is dp by d theta cross dp by dz, magnitude d theta dz. P is r cos theta I plus r sin theta j plus zk by d theta, means r minus sin theta I plus r cos theta j plus k. Cross product with dp by dz, where p is r cos theta I, r is h minus h by a, and r, I'm sorry, r, someone, okay, so r is h minus z into a by h, r by h minus z equal to a by h, r equal to h minus z by h into a cos theta. So it will, someone differentiate it with z, then it becomes minus 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 h minus z minus a by h, minus a by h cos theta I minus a by h sin theta j plus k. Now someone has to do cross product, and whatever comes, calculate the magnitude, then dz d theta. We calculated it actually meanwhile, and full integration from theta 0 to 2 pi, and then z is 0 to h, it comes as pi a, square root of a square minus h square. Someone can try it. Integration from 0 to 2a, and then 0 to h, and then dp by d theta dp by dz. dp by d theta is r minus sin theta I, where r is h minus z by h into a, minus sin theta I plus r cos r sin theta j, because dp by d theta we are doing. That's it. K will go away because it is zk. Cross product with, now with dz, so it will come as minus a by h, okay, z a, h minus z into a by h, minus a by h cos theta I minus a by h sin theta j plus zk difference with z will become only k. Calculate the cross product, take the magnitude, then dz d theta. It will come as pi into a square root of a square plus h square. So if I have a like this, cone like this, and then the a is this and h, then a square plus h square is the slant. If I say it s, then s, simple the slant length of the cone. So it will come as pi a s. So nicely we calculated this through cross Jacob. Cross Jacobian में d surface area by dxy into dxy, that I resolve it as dxy nothing but dxy by d theta z into d theta z, and then xy gone, and it becomes d surface area by 3 d theta z magnitude and d theta z becomes d theta dz, and this is cross Jacobian. The surface area in xy and the lower differentiation is in theta z plane. So surface area, if this is xy plane and this is the surface area, d surface area by, if this is theta z plane, d surface area over xy plane by by d theta z, d xy plane is gone. Cross Jacobian is coming into the picture. Amazing, mind blowing. Now someone can try, and then someone can try this cross Jacobian in calculation of the sphere. We'll do it. We are not running away. Cross Jacobian in calculation of the surface area of a sphere, surface area of a cylinder, surface area of anything. Okay. Now little bit we'll see the partial Jacobian. Partial Jacobian. Partial Jacobian, like if we are calculating the kind of, say, that volume of a sphere, if we are calculating volume of a sphere, volume of a sphere is nothing but fxy, volume of a sphere is nothing but fxy dx dy, fxy dx dy, and then x, and if I am calculating the volume of a sphere, then if this is the if this is the xy plane, if this is the xy plane, the sphere is centered at the origin. So half of the sphere is up, so half of the sphere is down. Hemisphere is up, one hemisphere is down, centered at the origin. Now upper hemisphere, if we say, then if there is a sphere that is tied here, it is fall in a xy region. Minus a to a to minus a to a is the x and y, that is the reason. Now integration over x minus a to a, y minus a to a, or circular region, and then fxy dx dy. So fxy, that is the z, is the square root of a square minus x square minus y square dx dy. No one can calculate, it is very difficult. Square root of a square minus x square minus y square dx dy. It is something that is very difficult. Now someone would say, I don't want spherical and I don't want cylindrical. Someone would suggest, why don't you go to spherical coordinate system? It will be pretty easy to calculate it. No, I don't want to go spherical or cylindrical. Please calculate in Cartesian only. Partial Jacobian comes into the picture. Now consider x equal to a square root of a square minus y square cos theta. X equal to square root of a square minus y square cos theta. What is this coordinate is? Theta coordinate system. Means if I talk in Jacobian, x coordinate system, then theta coordinate system, single dimension. X fx, theta function over theta, that is the x, theta and function over the theta is x. Here x and function over the x, whatever it is, z or whatever it is. The x equal to square root of a square minus y square cos theta. The actual integration is xy plane circular region, and then z fxy, that is square root of a square minus x square minus y square. This is a sphere of radius a. square root of a square minus x square minus y square dx dy. If that is the case, then now x equal to square root of a square minus y square, then x I can change now. Now square root of a square minus y square minus x square. X is x square has become now a square minus y square, and then in braces cos square theta. A square minus y square I can take it out, and it becomes square root of 1 minus cos square theta sine theta. Okay, so it becomes like, okay, so it becomes like square root of a square minus y square, square root of a square minus y square sine theta. And then here dx would change into square root of a square minus y square. The way it was, it is a constant. Taking it as a constant, cos theta is minus sine theta. If I place it, it becomes as a square minus y square. I believe I am correct. So it becomes a square minus y square minus sine square theta d theta. Okay, if that is the case, I can keep a square minus y square outside and minus and then bracket a square minus y square outside and sine square theta d theta. Integration of sine square theta is theta by 2 minus sine 2 theta by 4. Okay, now I have to place the limit. So x is minus a to a. Okay, why it is called partial Jacobian? Partial Jacobian because we did not change xy. Full is dx dy. Dx dy is xy plane. We did not change full xy plane, full coordinate system into another coordinate system. Half of it x I am changing. So dx dy, dx x I am transforming into theta. So dx is nothing but dx by d theta into d theta. This dx by d theta is Jacobian. Dx by d theta is Jacobian. So dx by d theta, what it is? That is minus sine theta. Dx equal to that is dx equal to square root of a square minus y square minus sine theta d theta. So dx by d theta is square root of a square minus y square minus sine theta. That is the partial Jacobian. So sine theta I kept it, and this side also sine theta came. Now I keep a square minus y square outside and multiplied by minus sine square theta. What about the limit minus a to a x is? So now x equal to square root of a square minus y square. Y is 0 on x-axis. So actually, if I'm trying the limit way, then x equal to, potentially it is when y equal to 0, a equal to x equal to a cos theta. If x equal to a cos theta, then when a is minus 1, cos theta equal to minus 1 pi. And when x equal to a, cos theta equal to a 1 0. So pi to 0. Now theta by 2 minus sine 2 theta by 4, then pi to 0. Sine 2 theta, if I take either 0 or pi, it is 0 1. So theta by 2, then pi by 2. Okay, and pi to 0. First I have to take 0. So full gone. Pi minus outside minus gone. It is pi by 2. So pi by 2 now I can keep outside, and a square minus y square I can take inside. Okay, that is the concept. Now a square minus y square dy, only x I did the drama. Now I have a square minus y square, a square y minus y to the power 3 by 3. Limit is minus a to a. So a, if I keep it, then a to the power 3 by a to the power 3 by 3. It becomes 2a to the power 3 by 3. Okay. Now minus a also, if I keep, it becomes 4a to the power 3 by 3. Outside 1 by 2 is there, 2a to the power 3 by 3. Okay, something like this. Then if that is the case, if that is the case, then it becomes, then now That's it. I believe this is what it is. So it becomes it outside I have pi already kept. So it becomes 2 pi a to the power 3 by 3. That is top hemisphere. 4 pi a to the power 3 by 3 is the volume of a sphere. This is partial Jacobian. We will use this partial Jacobian in calculation of surface area also. We calculated the volume of a sphere. Can I use partial Jacobian to calculate the surface area? We saw cross Jacob. D surface area in xy by d theta z. Amazing, right? Now partial Jacobian dx by d theta. dy we keep as it is. Now we will use in calculation of surface area of partial Jacobian for the sphere. Someone can try for the cone also. Who is stopping someone? Or cylinder, whatever. So that we will see. Please support us. Telephone number is +91, that is India country code, and 9483160610. +91 India country code, 9483160610. Please do support us. It helps. Okay, so we will see partial Jacobian further.